This is our third question on energy levels. If you haven't watched the first video on energy levels, I would recommend you go back and watch that video in detail, because in that video, I've explained how to answer questions on energy levels. I will not be repeating those details again in this video. I'll just tell you the steps that you need to follow. The first question is, calculate the ionization energy in joules for an electron in the negative 10.4 electron volt level. So the electron is sitting here. We need to get it out of the atom, which is this zero energy level. The energy difference between these two levels is 10.4 electron volts. We just need to convert electron volts into joules. Remember, we need a conversion factor to convert electron volts into joules, and the conversion factor that we need to use will be 1.6 times 10 to the negative 19 joules divided by 1 electron volt. You will see that the electron volt here will cancel with this electron volt, and you will get your answer in joules. The second question is, an electron has been excited to the negative 1.6 electron volt energy level. Show on the diagram all the possible ways it can return to the negative 10.4 electron volt level. So the electron is sitting here at negative 1.6, and we need to show all the possible de-excitations that will bring this electron back to the ground level, which is 10.4 electron volt. So the first will be to go from negative 1.6 to negative 3.7, then from negative 3.7 to negative 5.5, and then finally to the ground state. The second possibility will be to go directly to negative 5.5, and then from here it can go to the ground state. The third possibility will be to go from here to here, and then from here it can go directly to the ground state. And there is one last possibility. Can you figure it out? The last possibility is that it can go directly from 1.6 to 10.4. The last question is, which change in energy level will give rise to a yellowish line for which the wavelength is 600 nanometers in the Mercury spectrum? So the question they are asking us exactly is that for which de-excitation the electron will emit a photon that will have a wavelength of 600 nanometers. First of all, we will calculate the energy of photon for which the wavelength is 600 nanometers. We'll use this equation, hc divided by lambda. And if you substitute all of these values, remember I explained that if you use the standard units, you will get the final answer in joules. Now, in order to compare this energy in joules with the difference in energy levels, which is in electron volts, we need to convert this energy into electron volts. So in order to go from joules to electron volts, we will use a conversion factor, which will be 1 electron volt divided by 1.6 times 10 to the negative 19 joules. The joules will cancel, and you will get your final answer in electron volts, and you will see that the answer is 2.1 electron volts. Now you just have to find the two energy levels for which the difference in energy is 2.1 electron volts. You can stop the video, try to figure out the answer by yourself. I'll tell you the answer. The answer is negative 1.6 to negative 3.7. The energy difference between these two levels is 2.1 electron volts. So if the electron de-excites from negative 1.6 to negative 3.7, it will emit a photon that will have this energy.